Hi everyone. So today we will discuss the January 2022 P4 unused paper. Okay, question number 1. They say here find the first 4 terms of the binomial expansion in ascending powers of x of 2 over root 9 minus 2x, giving each coefficient as a simplified fraction. Okay, so then shall we expand this? How do we expand? What's the basic rule we use to expand here? Basically we use 1 plus x to the power n equals 1 plus nx plus n minus 1 x square over 2 factorial. I mean, how many terms do they want? Find the first 4 terms. So there's another one. The next one should be n minus 1, n minus 2, x cube over 3 factorial. So this is the expansion that we are going to use. So I need to apply this expansion on 2 over root 9 minus 2x. Are you with me? Okay, first we need to fix it. How do we fix it? Yeah, root is a power of half. Taking the power of half up gives me what? 2 times 9 minus 2x to the power minus half. But now still can I use this particular rule here? Not yet, because this is I need to have here a 1. I mean, basically here the plus x can be actually anything. It can be 2x, 3x, 5x. We can just replace the x value. However, it's mandatory that we have what here? That we have 1 here. We can't have a 9. So what should I do here? I'll take a 9 out. How do I take a 9 out? Now, do you see that there is a bracket? Outside the bracket, there's a power minus half. So when there's a power minus half, when the 9 comes out, it comes out as 9 to the power minus half. This comes out as 9 to the power minus half. What's remaining inside the bracket? You're taking a 9 out. So what's happening here? 9 divided by 9 is 1 minus just not 2x here. We are taking 9 out from both of these people. Okay, because you're taking it from the entire bracket out. So then it's going to be 2x over 9. You should know when you're taking a number out of the bracket, you take it out as a division. Basically, you take a 9 out from the bracket, means you divide both the components by 9. And since this bracket also has a power, when that 9 comes out, it comes out with that particular power. Okay, so now actually you can see I have this particular format, 1 plus x to the power n. So 2 into 9 to the power minus half is how much? 2 over 3, 9 to the power minus half, you can type, it's 1 over 9 to the power half, that's 3, yeah, so 2 over 3. Okay, so now it's time to use the expansion. So you replace, your x values are replaced by minus 2x over 9, your n value is replaced with minus half, and then you need to apply this equation. Okay, 2 over 3 is outside, let the 2 over 3 be there, you can use a large bracket like this and expand. 1 plus n is minus half, x is minus 2x over 9. Are you agreeing with what I'm doing? Replace the n here with the minus half, replace the x here with the minus 2x over 9, and then plus n is minus half, n minus 1 is minus half minus 1, and then minus 2x over 9 square. Divide by 2 factorial, I prefer to write as 1 over 2 factorial. So it's easier to type in the calculator. Okay. Basically, 2 factorial has to be in denominator. So it just needs to come down as a denominator. Okay. Make sure you replace the x with minus 2x over 9. So that's the first term, second term, third term. Also, you need to get the fourth term. Get the fourth term. N is minus half, minus 1. Next one. Minus half, minus 2, x cube. X cube is minus 2x over 9 to the power 3 into 1 over 3 factorial, and then you close the big bracket because you open one here. Do you see the expansion? So now it's time to type everything in the calculator. So first we'll solve each part separately. 2 over 3 here, 1. So let's start the next part in the cal. So each term separately. What do I have here? Minus half into, so you can't type the x here. So type the coefficient, minus 2 over 9. Do you see? Minus half into minus 2 over 9x, which gives me how much? Plus 1 over 9. What's the x value here? It's x here. Plus 1 over 9x. Do you agree? Can you understand this part? This is the answer here. Okay, now let's type the next term. So this particular term is entirely one person here. So let's type the whole thing in the cal here again. So we'll type, I get here minus half Yeah, into, let's give it with the bracket now, right? Minus half minus 1. So make sure you can give it with the bracket to be safe. Minus half into minus half minus 1. And the next part into, what is it? Minus 2 over 9. And you can't type the x, but you can, you can type the bracket, and outside the bracket type the square. Minus 2 over 9 square. And then into 1 over 2 factorial. So give the factorial sign. What's the factorial sign here? Yeah, here, this one. Okay, this one over here, the shift mark. Okay. So 1 over 2 factorial. Okay, I typed everything now. It's a type. I get 1 over 54. Is that correct? 1 over 54. And what is this? X square. Remember, the square comes to the x here. 1 over 54 plus 1 over 54 x square. That is the answer that I got for the yellow color part. Okay, and then the next part. Let's start the last term. So type the whole thing. There's a lot of type here. Minus half. So I will erase this part. Minus half into minus half minus 1 into minus half minus 2 close bracket, and then again into minus 2 over 9 close bracket to the power 3. Do you see? Into 1 over 3 factorial. This is okay? Okay, make sure you give here 2 over 9. You can't give the x here. 2 over 9 to the power 3, right? Can you see? I get 5 over plus 5 over 1458. Plus, right? Yeah. 5 over 1458. And what is this? X cube. Plus 5 over 1458. Am I correct? 1458 x cube. Yeah. So this is the last term. Do you see? So we are not done with it yet, because we have now again expand with what? 2 over 3. Can you expand with 2 over 3 all the terms? 2 over 3 into 1 is 2 over 3. 2 over 3 into 1 over 9. Multiply 2 over 27x. Plus 2 over 3 into 1 over 54. Can you multiply? How much? 1 over 81 x square. 2 over 3 into 1 over 54. You can type in the calculator. Next one, 2 over 3 into 5 over 1458 is 5 over 2187. Is that correct? X cube. Okay, so this is it. Okay, I didn't show this part with the multiplication. It's quite simple. You can multiply it with the calculator and get the answer. So this is the answer for part A, giving each term as giving each coefficient as a simplified fraction. Is this okay? Okay, moving on to part B. By substituting x equal 1 into the answer to part A, find an approximation for root 7, giving your answer to 4 decimal places. Okay, so what is the value? What did we find in part A? We found the binomial expansion of 2 over root 9 minus 2x, right? This is equal to 2 over 3 plus 2 over 27x plus 1 over 81x square plus 5 over 2187 x cube, right? This is what we got. Shall we replace x equals 1? When x equals 1, what do we get? 2 over. Replace every x with 1. Okay, root 9 minus 2 times 1 equals 2 over 3 plus 2 over 27 times 1 plus 1 over 81 times 1 square plus 5 over 2187 into 1 cube, right? Can you all get me the answer? This is 2 over root 9 minus 2 is root 7, right? And I want to get an approximation for root 7 as well. Can you all type this whole thing in the cal? What do we get? Yeah, I'll type 2 over 3 plus 2 over 27 into 1 means 2 over 27 plus 1 over 81 plus 5 over 2187. So I get, yeah, this answer 1652 over 2187. And then all you have to do is what? Make root 7 the subject. Make root 7 subject. If you want, you could rationalize up and down with root 7 and then make root 7 subject, or you could take root 7 here and take these to the other side. Which one do you prefer? You take the root 7 here and take these two the terms to the other side. Okay. So here basically 2 times 2187. Yeah, root 7 times 1652. You can do it at once, right? There's no need to waste steps. You can do this at once without writing this in 2 steps. You can go with it. We go with it in 1 step. So 2 times 2187 over 1652. Yeah, so this gives me the approximate value for root 7 and they want the answer to 4 decimal places. So type it 2 times 2187 over 1652. And I get here the decimal to 4 dB 2.64769, which means 4 dB 2.6477. 2.6477 is the correct is the answer of root 7 for 4 decimal places. This is okay. So this is the answer for question number 1. Moving on to question number 2. The curve C has parametric equations x equal t to the power 4 over 2t plus 1, y equal t cube over 2t plus 1. Write down x over y in terms of t, giving your answer in simplest form, and you can see it's how many marks? It's just 1 mark. So basically you can give your answer immediately and you would get that 1 mark. Okay, so what you need to see here is x and y. They both have the same denominator 2t plus 1, right? The difference is x has a t to the power 4, y has a t to the power 3. So basically, if you see the division, I think you might be able to see 2t plus 1, 2t plus 1 cancels, and t4 over t cube is actually t. If you can't see that, I'll show you how it's done, but you could write x over y equals t in one go. However, otherwise, I'll show it to you all like this. X is t to the power 4 over 2t plus 1. This is x. Divide by y, right? T cube over 2t plus 1. Do you agree? X divide by y, right? I wrote the x value here divided by the y value. And then we turn division to multiplication. And what happens? So basically what I was explaining, yeah, you need to see it if you can see it inside your head. And you can see that now the 2t plus 1 term cancels. T to the power 4 over t to the power 3 gives you t. I mean, it just gives you t. So x over y is simply t. And if you write this in one go, since it's 1 mark, you would get that 1 mark. Okay. Then we'll move to part B. Hence, show that all the points on C satisfy this particular equation. Okay, they wanted to show that the curve satisfies the equation. Basically, what do you think they are doing here? This is given to you in parametric form, right? So this is what form? This is Cartesian form. Basically, they have removed the t. They have found a way to get rid of the t. So we'll take one equation and then replace the t, because we already have a substitution for t, right? Who is t? X over y. We could just replace t with x over y and use any one. Use any one of the two equations. It's perfectly fine. It's perfectly fine. Any one of the two, and we can get the show that from either one. So use any one. I'll use x. X equal t to the power 4 over 2t plus 1. And what I'll do here is I'll replace t as what? X over y. I don't need to use any other different substitution, because they use the word hence here. Hence means definitely use the help of part A. Understood? So you must use the help of part A to get the marks. I mean, when they use the word hence, if you do in another way, you will not get the marks. So x equals t is x over y. So this is t to the power 4 over 2t is x over y, 2t plus 1. So x equals, this is x to the power 4 over y to the power 4. Shall I write here divided by? Divided by 2x over y plus 1. Do you understand my simplification here? 2 times x is 2x over y. Okay. Plus 1. So I just wrote it as a division. This sign as a division sign over here. Let's simplify. I get here x to the power 4 over y to the power 4. Division mark I still can't convert to multiplication until I make it to a common denominator here. So I'll make it to a common denominator. This is over 1. Let's multiply both up and down by y. 2x plus y over y. X equals x to the power 4 over y to the power 4. Now, since I took the common denominator as y, now I can turn division to multiplication because I have a common denominator. So I get here y over 2x plus y. Do you agree with me? So one y term will cancel. Is that okay? And I get here x equals x to the power 4 over 2x plus y. Is that okay? And then shall I take the 2x plus y to the other side as a multiplication? So x multiplied by 2x plus y equal x to the power 4. Actually, should I open the bracket with x, or do I have a method to simplify this x with x to the power 4? You can see if I bring this x is the multiplication at this point. We can take x to the other side as a division and we can get the x cube. Did I do a mistake? Y cube. Sorry. Yeah, y to the power 4. Sorry, y to the power 4. This is y to the power 4. When I cut with y, should be y cube. Yeah, so let me erase that. Yeah, sorry. X equals x to the power 4 over y to the power 3 when I cut a single y here, right? And then you get 2x plus y at the bottom. Is that okay? Then here I'll take the whole thing to the other side, x times y cube times 2x plus y over x to the power 4. Is this okay now? And now what I'll do is I'll keep the y cube 2x plus y here and take only the x to the other side because I can simplify x. So y cube times 2x plus y. I'll keep here the x multiplication. I'll take it to the other side as a division because I want to get rid of x here. Okay, so I get here y cube into 2x is 2x y cube. Y cube into y is y to the power 4. Is that okay? Equal x to the power 4 divided by x is x to the power 3. Is this okay? Take everything to the other side. We need to get the show that x cube minus 2x y cube minus y to the power 5. Then this is our show that x cube minus 2x y cube minus y to the power 4. Yeah, so this is our show that. So make sure you show all the relevant steps and the working because it's a show that. Okay. Okay, moving on to question number 3. The curve C has equation 3y square minus 11x square plus 11xy equal 20y minus 36x plus 28. Find in simplest form dy by dx in terms of x and y. Okay, so basically they wanted to find dy by dx. How do you find dy by dx? We differentiate, differentiating y with respect to x. So when you have 3y square, you know how we differentiate. The priority first goes to the power. So what happens? 3 when you have y to the power 2, you take the power 2 in front, and then you keep the y inside, and then 2 minus 1. First you take the power front and subtract 1 from the power. After you are done with the power, in differentiation, the priority goes to the power. First you deal with the power. After dealing with the power, go inside and differentiate the function inside the bracket. So who is it? We have a y. When you differentiate a y with respect to x, we say we get dy by dx. Are you clear with that? And then the next part, minus 11 times x square. X square differentiation is 2x. Basically, directly 2x. Do we have any dy by dx? No, the 2x to the power 1 and then into the x differentiation is 1 because we differentiate x with respect to x. That is 1. And then the next one, plus 11xy. Be careful here. Why? Why am I asking you to be careful here? Because there are there's a product of xy. When there's a product of xy, we had to use what rule to differentiate? We must use the product rule to differentiate. Okay, so that means one person waits while the other one differentiates. So 11 and x is waiting while y differentiates. Are you with me? 11x waits while y differentiates. Differentiation of y is what? Dy by dx. Are you guys with me? And in the next part, who is now waiting? 11 waits. 11 is anyway a constant now. Y is waiting. 11y waits while x differentiates. X differentiating with respect to x is 1 equals 20 times y differentiation is dy by dx minus 36x minus 36 into x differentiation is 1 plus 28 differentiation is 0. Is that okay? So I get here, we need to make dy by dx a subject. Let's simplify. 3 times 2, 6y dy by dx. 11 times 2 is 22x plus 11x times dy by dx plus 11y equals 20 dy by dx minus 36. Is that okay? So I need to take all the dy by dx terms to one side and the others to the other side. So let me keep 6y dy by dx here plus 11x dy by dx here, and there's another person with dy by dx here, right? The 20. So I'll bring it here as minus 20 dy by dx. Are you guys with me? And let's take all the terms without dy by dx to the other side. Who is it? The 11y I'll take to the other side and the 22x I'll take it to the other side. So what happens? Minus 22x goes as plus 22x, plus 11y goes as minus 11y, and here we have minus 36. Is that okay? Taking dy by dx out, I get here 6y plus 11x minus 20 equals 22x minus 11y minus 36. So when I make dy by dx the subject, the bracket 6y plus 11x minus 20 goes to the other side. It's a multiplication here. So it will go to the other side as a division. Is this clear? This answer, some of you might get the answer slightly differently with the sign change. You might get the answer for dy by dx as minus 22x plus 11y plus 36 over minus 6y minus 11x plus 20. If you get this, the answer here with the same figures, but the signs of each and every term is different, that answer is also acceptable. Okay, but all the signs should be the opposite of this. That's also okay. Okay. That is, if you take that happens if you take all the dy by dx terms to the other side over here, and you keep the normal numbers on the left side. Okay, in that case, you would get the same answer, but the signs would be totally changed for every time. But both the answers are exactly the same. Okay, right. Let's move to the next part. The point P 4 comma k where k is a constant lies on C. So the point P 4 comma k where k is a constant lies on C. Given that k is less than 0, which means what? K is a what figure? K is negative. Given that k is negative, find the value of the gradient of C at P. Okay, the first thing you should do is what? The first thing you have to do here is you have to get the value of your k. So were you able to determine what's the k value? What should you do here? First, you should replace your x values with what? X values are all supposed to be replaced by 4. Replace x value with 4 because they say here P is 4 comma k, right? So 3k square minus 11 into 4 square plus 11 into x is 4, y is k, 20y is k, minus 36 times 4 plus 28. 3k square, 11 into 4 square, how much is it? 16 times 11 is? And then we get here 44k equals 20k minus 36 times 4 is? Yeah, minus 36 times 4 and then plus 28. We'll add them all together. Minus 116. Then taking everything to one side, 3k square plus 44k minus 20k is plus 24k. And then plus 176, sorry, minus 176, this comes as plus 116, right? Minus 176 plus 116 is 60. What 60? Minus 60. So basically we get a quadratic equation with k. I think everyone is divisible by 3. Shall we divide everyone by 3? What do we get then? K square plus 8k 3 times. Yeah, and then simplify. Do we get good answers here? What are the answers we get? K minus 2, k plus 10. So then when you simplify here, we get k minus 2 equals 0 or k plus 10 equals 0, which gives me k equals 2 or k equals minus 10. So out of these two answers, which one do you think I should take? We must take k equal minus 10 because very clearly they have told us k is less than 0. K is negative. Therefore, since k is negative, the correct k value should be minus 10. And they're asking you to find the gradient of the curve at P, right? So basically the gradient dy by dx is already found in part A. All you have to do is what? Substitute the gradient at where? The p coordinate is now 4 comma minus 10. So you have to get the dy by dx at 4 comma minus 10, isn't it? So replace dy by dx answer was what? 22x. Remind me again. 22x minus 11y minus 36 over 6y. So dy by dx equals 22 times x is 4 minus 11 times y is minus 10 minus 36 over 6 times y is plus 11 times x is 4 minus 20. Can you all type this in the calendar and get me the answer? Yeah, you can type this in the calendar. I'm not going to type this part. You can do it. Okay, so minus 9 over 2 immediately, and that's the value of your dy by dx at the point P. Okay, is this okay? Okay, we'll move on to question number 4. They say fx equals 4 minus 4x over x, x times x minus 2 square, express fx in partial fractions. First thing is, always when you are going to write something in partial fractions, check whether this is an improper fraction or a proper fraction. Is this improper or proper? Look at this, the numerator's order. The highest power of x is x to the power 1. While the denominator has the highest power of x here, what? There's inside this bracket, there's a x square, and multiplying with another x, you get x cube. So definitely the order of the denominator is higher. Okay, therefore this is a proper fraction. In an event it's an improper fraction, the way we write partial fractions is slightly different, right? So you have learned the theories in your P4 book. Okay, so I'm going to write the partial fractions for an improper fraction. Okay, so let's break the partial fractions here. 4 minus 4x over x times x minus 2 square. Okay, how does it work? We'll write a over x, and then when you have a power x minus 2 square, how do we write? B over x minus 2, and then it's not over, plus c over x minus 2 square. Are you guys okay with that? Okay, so then let's take the numbers for the 4 minus 4x here. A over x multiplies with x times x minus 2 square. What happens? X and x cancels and I get x minus 2 square. Shall I write it immediately? Do you, I mean, is it clear what I'm doing here? The x times x minus 2 square goes to the other side and multiplies with the a. So when the x and x minus 2 square comes on top here, the x to x cancels and the x minus 2 square remains. With b, what's remaining? Now here with b also, you get on top here x times x minus 2 square. What happens? There's x minus 2 square, there's a x minus 2 down here. So one of x minus 2 cancels and you get here what? Bx times x minus 2, because there's a square coming up here. And the next one, for the c also we get x times x minus 2 square. The x minus 2 square will completely cancel out, leaving what here? Cx. Are you okay with that? Okay, so now it's time to input values for x. So we can say what? When x is, give a values that makes your bracket 0, when x equals 2, for example. When x equals 2, what do we get? 4 minus 4 times 2 equals a times 2 minus 2 is 0, plus b times 2 times 2 minus 2 is 0, plus c times 2. 4 minus 8 equals, here this is 0, this is b times 0, and here this is 2c. 4 minus 8 is minus 4 equals 2c, thereby c equals minus 4 divided by 2 is minus 2. Are you okay with that? Okay, then moving to the next part. When x equals, the next good value we can go when x is 0. Why am I choosing these values? Because I can see when x is 0, 2 of the terms will become 0. And I'm only remaining with the a term. Do you see? You can use any value you want, but I'm strategically choosing x values that makes a few of the terms 0. Okay, so I'm strategically choosing my x values. So when x is 0, I get here 4 minus 4 times 0. Okay, using x as 0 into this equation. I get a times 0 minus 2 square plus b times 0 into 0 minus 2 plus c times 0. Basically, what's happening? 4 minus 4 times 0 is 0. Here a times minus 2 square. What happens to both these terms? B multiplied by 0. Basically, anything multiplied with a 0 is completely a 0. Here c times 0 is 0. Okay, so then I get here 4 equal a times minus 2 to the power 2 is minus 2 to the power 2 will be plus 4. You need to be careful of that. Minus 2, when you square it, it's going to be not minus 4, but plus 4. Make sure when you're squaring it, if you're giving it in the cal, the power 2 needs to be outside the bracket. Okay, minus 2 within brackets and power 2 outside the bracket should give you 4. And then what do you get for A? 4 divided by 4, right? 4 goes as a division. 4 divided by 4, A is 1. Okay, so I got the value of C and A. I now need to get the value of B. So to get the value of B, now you could use, since we know A and C, you could go with even, there are other ways here. You could compare coefficients. There are many ways of getting it done. So I could again use any X value that I really want because I already have C and A. And I can get the remaining value B. Are you okay with that? So shall we say, tell any value you like. You can even go with comparing coefficients. There's absolutely no problem. Okay. I think comparing coefficient would maybe give you the answer slightly faster. Okay. So I'll use when X is 2, when X is 0. Tell me any X value you like now. When X is 1, you can use X is 2 or 10 or 100 or whatever. Okay. You should get the same answer. So 4 minus 4 into 1. A times 1 minus 2 square. B times 1 minus 2. Are you with me? Plus C times 1. What do I get here? 4 minus 4, right? A times 1 minus 2 is minus 1 square. Here B into 1 is B. 1 minus 2 is minus 1. C into 1 is C. Are you following me? 4 minus 4 is a 0. 4 minus 4 is a 0. A into minus 1 square is a plus 1, right? Because minus 1 to the power 2 is minus 1 into minus 1 is plus 1. So basically I get A into 1 is A. B into minus 1 is minus B. Plus C. Are you with me? Let's input the A value is 1 we found. B value is unknown. C value is how much? C value is minus 2. Are you with me? I'll take the minus B to the other side because I want to make B subjected. So plus B equals 1 minus 2 is minus 1. Do you see? Okay, so I have the ABC values now. I can write my partial fractions. Shall we write the partial fraction? B is minus 1. Okay, so let's write the partial fractions. 4 over 4 minus 4x over x minus 2 square equals. Replace the ABC values here. Okay, so replace it and tell me. 4 minus 4x over x times, what was the fraction? X times x minus 2 square, right? Equals to what? 1 over x plus minus 1 over x minus 2 plus minus 2 over x minus 2 square. Basically, I just replace the ABC values. Okay, agreed? Okay, so these are my partial fractions and this is the answer for part A. Okay. Moving on to part B, they say hence find the integration of fx with respect to x. So they're asking you to what? Integrate this fx. So basically, how do we, and they use the word hence here again. Hence means what? Use the help of part A. Use the help of part A. So integrate fx. Now we already have our fx here in part A, right? So then instead of integrating the 4 minus 4x over x minus 2 square, we integrate this guy, which is easy to integrate. So integration of fx. In other words, is to integrate 1 over x minus 1 over x minus 2 minus 2 over x minus 2 square. Are you with me? So I'm going to integrate this. So we can integrate, I'll separate these terms out. Integration of 1 over x minus integration of 1 over x minus 2. The integration of minus 2. Basically, now these terms we can directly integrate, right? I think you should know 1 over x integration is ln x. 1 over x minus 2 is also integration is ln x minus 2, right? Because we have the integration rule. Are you aware of the integration rules? Okay, so I think, yeah, these are the integration rules. Can you see? 1 over x plus b rule here. 1 over x plus b rule is exactly what we are using here to integrate. Okay. So basically, before I go into any of that, the thing is, how do we integrate 1 over x minus 2 square? Do we have x minus 2 square? Can I use this the ln rule for x minus 2 square in the denominator? Definitely no, because for this, there should not be any power in the denominator. So for x minus 2 square, we need to go with what? Rule number 1, where we need to take it up and have it as a power. Okay. So here I will take minus 2, I'm taking it out, and x minus 2 to the power 2 goes up as x minus 2 to the power minus 2. Do you see what's going on here? X minus 2 to the power minus 2 comes up here. Okay, let's integrate. 1 over x integration is ln x. This is minus ln x minus 2. And we have a 1 over a, but it's just 1x here. So no problem here. Minus 2 times x minus 2 to the power minus 2. When you integrate, x minus 2 to the power minus 1 over minus 1. Okay, and then don't forget the plus c. Okay, and here also I'm not having, if you have a x coefficient, you must divide with the x coefficient. Here I have 1x, therefore it's okay, we don't need to divide. Or else basically we need to have that a value here. Do you agree? 1 over a, the x coefficient value we need to divide. So in this case it's 1x. Okay, so the answer is ln x minus ln x minus 2. Minus 2 and the minus 1 here, division. Minus 2 over minus 1 is plus 2 times x minus 2 to the power minus 1. Now you can say plus 2 over x minus 2. Okay, and then we have finally what? Plus c. Is this clear with you all? Moving on to part C, they say find the integration of fx. They have given you the definite integration. Basically, they have given you the limits, right? From 3 to 5, giving you answer in the form a plus ln b, where a and b are rational numbers to be found. So a and b are rational numbers. Rational numbers means what? They are fractions. Okay, rational numbers are fractions. Basically, you need to see fractional answers here. Okay, so I think we already integrated, right? In part B, we have already integrated. All we need to do is now what? Just input the limits into our integrated answer and then get the show that. So from 3 to 5, shall we? Integration of fx from 3 to 5. Already I have integrated, so I'm going to input the limits. Ln x minus ln x minus 2 plus 2, shall I have 2 over x minus 2? Are you okay with that? Because x minus 2 to the power minus 1 is 2 over x minus 2. Plus c is not necessary when we put the limits, because plus c will actually cancel out when you put the limits, because there's no x to substitute over here. When we put the definite integration, we don't need to use the plus c. So what do we get here? Ln 5 minus ln 5 minus 2 is 3 plus 2 over 5 minus 2 is 3, right? Minus, then replace the x with 3, ln 3 minus ln 3 minus 2 is 1 plus 2 over 3 minus 2 is 1. Do you agree with me? Ln 5 minus ln 3 plus 2 over 3. Here I get minus ln 3. So, you all know about ln 1, right? Ln 1 is 0. Basically, logarithm, any logarithm with, you take it with 1, logarithm of 1 to any base is 0. And here, minus into plus is minus 2. And then let's take it to a single logarithm. Ln, can you take it to a single logarithm? 5 minus ln 3 means the 3 comes down. And here again there's a minus ln 3, which means this 3 also comes up or down? Comes down. Are you with me? I'm considering these terms, these 3. Ln and then positive ln, because it's a plus ln 5, the 5 comes on top, minus ln 3, 3 comes down. Again here minus ln 3, the 3 comes down. Okay. And then over here I have plus 2 over 3 and minus 2. Can you all simplify? I get here ln 5 over 9 minus or plus 2 over 3 minus 2 is minus 4 over 3. Yeah. And this is our answer. Actually, they asked us to get the answer in ln a plus ln b, right? A plus ln b, where a and b are rational numbers. Okay, so we have here a plus ln b, where a and b are both rational numbers. Isn't it? Is this clear? So this is the answer for part C. Okay, moving on to question number 5. With respect to fixed origin O, the lines L1 and L2 are given by the equations. L1 is okay. They've given you the R equal A plus lambda B. You know here, the first XYZ here represents the position vector on the line, right? You know the format of a straight line, R equal A plus lambda B, where A represents the position vector on the line and B represents what? B represents the direction vector of the line. Basically, it gives an idea of how the direction that the line is moving. Okay, so they say here, show that line 1 and line 2 meet and find the point position vector at their point of intersection. Okay, how do we find the place where they meet? Shall we add the, now you know, R here represents any general point on your line. R represents any general point on line L1. Here R represents any general point on line 2. When they intersect, what happens? The R values will become, when they intersect, the R values become equal. So equate them. First I'll add here 4 plus 2 lambda. Here I get 4 minus 3 lambda. Here I get minus 5 plus 6 lambda, right? So from line 1, I added the coordinate, the position vector and the direction vector. And I'm getting a XYZ general coordinate. I'm getting a general coordinate on top of line 1. Similarly, get a general coordinate on top of line 2. 13 plus 5 mu minus 1 plus mu, 4 minus 3 mu. And now what do we do? Make them equal. So 4 plus 2 lambda equals 13 plus 5 mu. Equate them and get one equation. What do you get here? 2 lambda minus 5 mu. 13 minus 4 is 9. Are you with me? I just made one equation. 2 lambda minus 5 mu equals 13 minus 4 is 9. Is this okay? So this is the first equation. The second equation, how do we create? Take it from the second person. Who is the second person? 4 minus 3 lambda equal minus 1 plus mu. Are you with me? So I get here. Okay, so this is the second equation. Basically, you could get lambda mu to one side and make another equation and solve it simultaneously. Or else what I'll do here is I'll do a substitution. 4 minus 1 goes as plus 1. That's 5 minus 3 lambda equals mu. Are you with me? Then I'll substitute this mu value into this mu value over here. Okay, what do we get then? 2 lambda minus 5 times mu is, who is mu? 5 minus 3 lambda equals 9. So we get here 2 lambda minus 5 into 5 is minus 25. Minus 5 into minus is plus 15 lambda equals 9. Can you all add 2 lambda plus 15 lambda is 17 lambda. 9 plus 25 is 25 plus 9, 34. 34. 25, right here? 25 plus 9. Then lambda equals 34 divided by 17 is 2, right? Yeah, and then let's substitute the lambda value into one of the two equations and get mu. So mu is 5 minus 3 lambda. Five minus 3 times lambda is 2. How much is it? 3 times 2 is 6. Mu is minus 1. Is that okay? Mu is minus 1. Okay, now how do we show that they meet? I mean, they're asking us to show, show that line 1 and line 2 meet. So basically, I found lambda mu. Now I only use the first two equations. Now substitute the lambda mu values to the third equation. What's the third equation? Minus 5 plus 6 lambda equal 4 minus 3 mu. Substitute. So you can substitute here the what was the lambda value is? The lambda value is 2 and mu value is minus 1, right? We substitute and see whether they are equal. Minus 5 plus 6 times lambda is 2. How much is it? Minus 5 plus 12, which is 7, right? On the other side, we have 4 minus 3 times mu is minus 1, which is 4. Minus 3 into minus 1 is plus 3. 4 plus 3 is 7, and they are equal. So therefore, what we say? Therefore, lines intersect. The lines are intersecting because they are equal. Third equation is working out. And then to find the point of intersection, what should we do? You can go with any one of these 2 points. Substitute either for this one, you can work substitute lambda as 2 and get the cutting point, or you could go to the other one, replace mu with minus 1 and get the cutting point. So any one of these 2 is okay. Anyone is okay. I'll go with lambda equal to the point of intersection. Four plus 2 lambda. Can you all tell me the point of intersection? 4 plus 2 lambda, 4 minus 3 lambda, and minus 4 plus minus 5 plus 6 lambda. So substitute lambda as 2. What do we get? 4 plus 2 times 2 is 4, right? 4 plus 2 times 2 is a 4. 4 minus 3 times 2 is 6. Minus 5 plus 6 times 2 is 12. How much do we get? 4 plus 4 is 8. 4 minus 6 is minus 2. Minus 5 plus 12 is 7. So 8 minus 2, 7. So point of intersection is basically point of intersection is 8i minus 2j plus 7k. Is this clear? Moving on to part B, they say find the acute angle between L1 and L2, giving your answer in degrees to 1 decimal place. Okay, so when they give you two straight lines and they ask you to find the angle between the two lines, what do? The normal rule for finding the angle is we use A dot B equal modulus A times modulus B times cos theta. This is the normal equation we use to find the angle between two vectors. Okay, so when you have two vectors, say we have vector A and vector B, so the angle between vector A and B is found by using this particular equation, meaning cos theta is A dot B over modulus A times modulus B. If you take the modulus of A dot B also, you can get an acute angle, because sometimes A dot B might be negative and you might get an obtuse angle. But if you take the modulus of A dot B, you'll end up getting acute. Okay, or else if you do get the obtuse angle without using the modulus, you can subtract that obtuse angle from 180 and get the acute angle. Okay. Okay, so shall we get, and by the way, when we say A dot B here, what are A and B supposed to represent in our straight lines? Can it be any vector on the straight line? No. When we say A dot B and we want to find the angle between our two straight lines, definitely the A and B here is supposed to be what? The A and B here is supposed to be the direction vector. Okay, the A and B here is supposed to represent the direction vector of the line. Okay, so here A and B represents the direction vector. So what's the A and B here? The direction vector of the first line is 2 minus 3, 6. The direction vector of the second line is 5, 1 minus 3. So shall we take the direction, the dot product of two direction vectors, A dot B? Two minus 3, 6. Dot product with 5, 1 minus 3. What do we get? 10 minus 3 into 1 is minus 3. 6 into minus 3 is minus 18. How much do we get? Minus 11. Okay, minus 11. Yeah, so then it's if you want to get the acute angle, better you make it, it's better that you make it plus, right? Okay, substitute the values to the equation. And then modulus A. Okay, before we apply to the equation, we'll find modulus A. So we have to get the square of all the square and the root of it. Can I know how much is modulus A? 7, directly 7, root 49, which is 7. Modulus B is 5 square plus 1 square plus minus 3 square and root of this. Can I know how much this is? Root 35. Okay, so it's now we are ready to substitute values into our equation. Let's get the angle. Cos theta is A dot B, which is minus 11 over modulus A is 7 times modulus B is root 35. By the way, now if you take the cos inverse of this value, definitely you will get obtuse, because you get your A dot B as a negative answer. So you can get this answer, subtract from 190. Or the other way is that you can directly what? Take the positive value, take the modulus of this, make it positive, and then get the cos inverse, which would directly give you what? The acute angle. Okay, so get cos inverse. Your cal must be in degree mode, right? They want the answer in degrees. Yeah. So cos inverse 11 over 7 times root 35. Are you with me? What do I get? 74.596. They want the answer to 1 dp, right? So 74.6. 74.6 degrees. Are you okay with this? Okay, so also just to show you the other method, if you do type cos inverse minus 11 over 7 times root 35, okay, so if you give this in the cal, you get 105, which is definitely what answer. It is obtuse, but they say in the question they clearly want an acute. So what you can do is you can do 180 minus your answer and you get 74.596, which is 74.6. Again, the same answer. Okay, so any method is fine. Okay, let's move to the next part, the last part. A circle with center A and radius 35 cuts the line 1 at the points P and Q. Given that the x coordinate of P is greater than the x coordinate of Q, find the coordinates of P and the coordinates of Q. You know what? Shall we first draw a kind of a diagram to help us have an idea of what's happening here? Okay, so we already found the acute angle between the two lines also, right? Shall we draw the two lines? So line 1 and line 2, they make an acute angle of how much? How much was it? 74.6. So the theta angle. We know the theta angle between L1 and L2, right? Okay, and then what do they say? A circle with center. Basically, wait, we know the cutting point here as well. Can I know the point of intersection here? We found in part A. 8 minus 2, 7. Let's say the point of intersection is X. Have they told us any name? Point of intersection is A. They've given us in the question. Point of intersection is A. Here, the point of intersection is A. So draw the diagram. So this is the theta, the point of intersection is A. So a circle with center A and radius 35. So basically I have to draw here a circle. Let me draw. So I'm just randomly drawing here. Okay, so basically that's a circle A with radius 35, okay? The circle A has radius 35. And they say the circle A with radius 35 cuts the line L1 at the points P and Q. Do you see the points P and Q? We are given that the x coordinate of P is greater than the x coordinate of Q, which means P is in front, right? So if I count what I have drawn, P should be having a greater x value, which is P is to the right. Q should be more to the left, right? So the circle cuts the line 1 at the points P, Q. Given that the x coordinate of P is greater than the x coordinate of Q, find the coordinates of P and the coordinates of Q. So they have told you the radius is how much? The radius is 35. Okay, so how do we get the coordinates of P and Q? How do we get the coordinates of P and Q? Basically, I know the AP distance, right? Okay, so one way to do this is, children, what we do here is we can get a general coordinate that lies on line 1. What do I mean by that? Now, you know here, basically, when you take line 1 here, they have given line 1 in terms of a parameter, right? So, did you see that I wrote over here when I was doing line 1? Did you see the way I wrote here and I was naming this as a general coordinate on line 1? When I added 4 plus 2 lambda, 4 minus 3 lambda, minus 5 plus 6 lambda, I told you this represents a general coordinate on line 1. Basically, any coordinate on line 1 is following this. You just need to put the lambda value and you can generate every single point that lies on line 1. So then, now you know P and Q are both lying on line 1, right? Which means what? P and Q must both satisfy that equation. So can I have the general coordinate of P and Q? The general coordinate of any point on line 1, of a point on line 1, or basically it could be P coordinate or it could be Q coordinate. What's the general point of any coordinate on line 1? Say it to me again. 4 plus 2 lambda, 4 minus 3 lambda, and minus 5 plus 6 lambda. Basically, I could use it as OP. So the P coordinate, let me take it as 4 plus 2 lambda, 4 minus 3 lambda, minus 5 plus 6 lambda. I'll take that as my P coordinate. I could even take it as my Q coordinate. I'll work with P now. Okay, the thing is, I know the distance A to P, right? I know the AP distance as 35. Are you with me? The radius is 35. So what can we do here? We know an equation that gets us the distance between two coordinates, right? What's the equation that gives the distance between two coordinates? Distance equals x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square holding square root. Right? So else what I can do with the root, I'll remove to the other side and make it what? D square. Is that okay? D square equals x1 minus x2 square. Shall we put the x1, x2 values? Who are x1 and x2? So I can say x1, x2, x1, y1, z1 is this P. Let's take it as P. It's easier. And x2, y2, z2 as A. Are you with me? These are the 2 points, x1, y1, z1, x2, y2, z2. So let's input x1 minus x2, 4 plus 2 lambda, minus x2 is 8 square. Y1 is 4 minus 3 lambda, y1 minus y2 is minus 2. Do you see the way I'm applying this? 4 minus 3 lambda is y1 minus, the middle minus mark is there, y2 is minus 2. Plus z1 is minus 5 plus 6 lambda, z1 minus z2 is 7. Are you with me? So distance actually value we know, right? Distance is 35. So 35 square. Can you all get the value here? 2 lambda, 4 minus 8 is minus 4 square. Then here I get minus is plus. 4 plus 2 is 6. 6 minus 3 lambda square. And here I get 6 lambda minus 5 minus 7 is how much? Minus 12 square. So open the bracket and you will end up getting what? A quadratic equation with lambda. Are you with me? We get a quadratic equation with lambda that gives us what? It generates two values of lambda. So those two lambda values gives you what? One lambda value will give you the p coordinate, the other lambda value will give you the q coordinate. Okay. So this is how we do these kinds of questions. Can I know the value of 35 square? How much? 1225. 2 lambda minus 4 square. Yeah, so we get here 4 lambda square plus 4 times 2, 8 times 2, 16. I'm opening the bracket immediately. Okay, 2 lambda minus 4 squares, 2 lambda minus 4 into 2 lambda minus 4. And then you have to open the bracket manually. Plus 16. This is 36. 6 times 3, 18 times 2 is how much? 6 times 3, 18. 18 times 2 is 36 lambda plus 9 lambda square. I'm opening this immediately. The next one. 6 lambda is when you square 36 lambda square. 6 times 12 and times 2 is how much? How much? Minus. So minus 100. No, 6 lambda into minus 12. So that is minus 72 into again a 2. Okay. Yeah, minus 144 lambda and minus 12 square is plus 144. I think I have made a slight mistake here. 2 lambda minus 4 square, the opening this guy, ne? Yeah, 4 lambda square, 2 lambda into minus 4, minus 8 times. This should be minus. Okay, so we can open the bracket. I open the bracket immediately by using a plus b square is a square plus 2ab plus b square. I was using this immediately. Okay, I did not show the working. But I was using a plus b square and a minus b square. I was basically using these two rules. Are you with me? I was using these two rules to open all of them immediately. Okay. So this is what I was doing. Can you all simplify and tell me what I get here? 1225 equals. Can you all add all the lambda square values here? 4 lambda square plus 9 lambda square plus 36 lambda square is 49 lambda square. Can you all add all the lambda values? Minus 16 lambda, minus 36 lambda, minus 144 lambda is minus 196 lambda. Then add all the constants plus 16 plus 36 plus 144. How much is it? How much? Plus 196. Take all the, make it equal to 0. 49 lambda square minus 196 lambda plus 196 minus 1225 is how much? Minus 1029. So I get this quadratic equation. Okay, so now you need to check whether this equation is divisible, because if it's divisible, it would be a lot easier. So check whether 49 is of course a factor of 7. So you can check whether it divides by 7. There's no point of checking it with any other number. Either it divides by 7 or it should completely divide by 49. Okay, what happens if when you try it completely divides by 49? Yeah, it completely divides by 49. So I'll divide the whole equation by 49. You need to realize 49 is 7 times 7. So at least we could try to divide it by 7. At least. Okay, but here we can divide it by 49. You can see it's a trial and error. So here we get here lambda square. Can I know how much is minus 196 divided by 49? 4 lambda. The other one? Minus 21. Okay, and then it's a quadratic equation, a simple quadratic equation. Can I know the two lambda values? Lambda minus 7 and lambda minus 7 and lambda plus 3 are the two factors. Basically, I get lambda equals 7 or lambda equals minus 3. Okay, so then let's substitute those two lambda values into the R equation and get the P and Q coordinate. R is 4 plus lambda. Tell me the equation for R. 4 plus 2 lambda. 4 minus 3 lambda. Right, so this is the R value, isn't it? Yeah, so now let's input the value of lambda. When lambda is 7, what do we get for R here? Substitute 4 plus 2 times 7, 4 minus 3 times 7, minus 5 plus 6 times 7. How much is it? 2 times 7, 14. 14 plus 4 is 18. The other one, minus 17. Next one, 37. And when lambda is equal to minus 3, can you all tell me the R value? 4 plus 2 into minus 3. 4 minus 3 into minus 3. Minus 5 plus 6 into minus 3. How much is it? Minus 2, 13, minus 23. So basically now you have to also, they ask very clearly who is P and who is Q. They have told you the x coordinate of P is higher, right? So thereby who is P? You can see the x coordinate of one here, the first one is 18, the other one is minus 2. So x coordinate of P is higher. They have said it in the question. Therefore, who is the P coordinate? The P coordinate is 18, minus 17 and 37. And the Q coordinate is minus 2, 13, minus 23. Basically, we should, these are column vectors. I think to give coordinates, let's write it down in the, like this, 18, comma, minus 17, comma, 37. And Q coordinate is minus 2, comma, 13, comma, minus 23. Are you with me? So these are the coordinates, the values of P and Q. Okay. Is this clear with you all? Okay, so now we'll move on to question number 6. They say use integration by parts to show that integration of e to the power 2x cos 3x dx is equal to this. Okay, so now I have written over here the integration by parts rule. Okay, so integration of u v dash. Basically, we have a product of two x terms. So when we integrate the product of two x terms, we can use integration by parts. However, when you are doing integration by parts, one person is chosen to be differentiated while the other is chosen to be integrated. So here u is the person we choose to differentiate and v dash is the person we choose to integrate, because you can see u has become u dash here, which is differentiation. V dash has become v here, which is integration. So basically here, when I'm trying to do this integration, e to the power 2x cos 3x, we need to choose one person to be our u, one person to be our v dash. Basically, we would choose u to be the person who is easily differentiable. And the v dash is the person who is easily integrating. But you can see here both terms are differentiating. Both terms are also integrating. And by continuous differentiation, do you think I can, is it possible to make any of these two either individual equal to 0? No. So therefore, what we do here is you can choose u and v dash in any way you like. So if you want, you can use u as e to the power 2x and v dash as cos 3x. Or you could use v dash as e to the power 2x and u as cos 3x. There's absolutely no problem. Whichever way you do is fine, because here both are differentiable and integratable. Okay, so then shall we write the u and v dash, u dash, v dash. So u is e to the power 2x. What is u dash? 2 e to the power 2x. V dash is cos 3x, which means v is integration. Can I know what happens when you integrate cos? 1 over 3 sine 3x, positive, right? Cos integration is positive sign. Okay, so you need to look at the integration rules. Okay, this is integration. So therefore we divide, not multiply. Yeah, integrating. Cos ax is 1 over a sine ax. So I have given you the integration rules, right? I've given you the integration rules. So here, these are the rules of integration. Okay, so cos ax plus b is 1 over a sine ax plus b. So these are the general rules of integration. Okay, shall we apply it here now? Integration of e2x cos 3x with respect to x equals uv minus vu dash, right? Shall we input the values? U. So u is e to the power 2x. V is 1 over 3 sine 3x. uv minus integration v is 1 over 3 sine 3x. U dash 2e to the power 2x with respect to x. Shall we simplify this a little bit? I get here 1 over 3 e to the power 2x sine 3x minus, I can take the 2 and 3 out as 2 over 3 e to the power 2x sine 3x. I just slightly rearrange the equation. Okay, are you okay with it? So now we come to the next part. The next part is, you can see again I end up getting an integration, a product. Okay, e2x sine 3x. So in this case, what we do is again we will go for parts by integration. So okay, it repeats the cycle again, and we will end up again getting, I want to repeat the cycle again because I want to create this. The thing is, when you use parts by integration, the integration doesn't end because you again get a part with the integration. So for that part, I'm again going to use parts by integration in order, I'm trying to create this original part over here again. Okay, so that's what I'm trying to do here. Look what I'm doing. So again, I will use my e to the power 2x as u and sine 3x as v dash. Okay, so try to go in the way you chose originally, because I chose initially also u as e to the power 2x. I go in the same manner. So in this case, u is e to the power 2x, which means u dash, differentiation of e to the power 2x is 2e to the power 2x is differentiation. V dash is sine 3x. V is integration of sine is, so I think I have written here, right? Integration of sine is minus 1 over a cos ax plus b. Can you see? So basically it's minus 1 over 3 cos 3x. Okay, so we are ready. Now it's time to input the limits here. Shall we? So I get here 1 over 3 e to the power 2x sine 3x minus 2 over 3 times. I'll put a big bracket here, and it's time to put our uv minus vu dash. Okay, so u is e to the power 2x, v is minus 1 over 3 cos 3x. Okay, so uv minus vu dash, integration v is minus 1 over 3 cos 3x, u dash is 2e to the power 2x. Are you okay? I've written it down over here. Is that okay with y'all? This should be written, but since there were no, I just wrote it down over here. Okay, then let's rewrite the sum again. So I have here integration of e to the power 2x cos 3x dx is equal to what? 1 over 3 e to the power 2x sine 3x. Okay, minus 2 over 3. Shall I open the bracket with minus 2 over 3? Are you okay with it? Wait, let me do it in the next step. You could, like, lose a few steps here. Minus 1 over 3 e2x cos 3x minus integration. I can bring this minus mark out, right, with this minus mark and make it what? Plus, and I can take the 1 over 3 out, and I get here, I can actually, sorry, I can take 2 also out, right? I can take this 2, I can take the 1 over 3 along with the minus, along with this minus, altogether plus 2 over 3 integration of e to the power 2x cos 3x. Okay, you shouldn't write like this in these spaces. Okay, I'm just running out of space. I need to make the lines bigger. Okay, so then let me make it bigger. So I get here e to the power 2x cos 3x dx equals, can you all tell me what I get here? 1 over 3 e to the power 2x sine 3x minus, shall we open the bracket? Yeah, we'll open the bracket. Minus 2 over 3 into minus is plus 2 over 9 e to the power 2x cos 3x, and the other part will be, it's going to be minus 2 over 3 into plus 2 over 3, which gives you how much? Minus 4 over 9 integration of e to the power 2x cos 3x. with respect to x. Are you okay with that? Okay, so then now I think you can see that we have the similar term here, e2x cos 3x integration, e2x cos 3x integration. So what I'll do here is I'll bring this term to the other side. So I have here integration of e2x cos 3x dx plus 4 over 9 integration e2x cos 3x dx equals to 1 over 3 e to the power 2x sine 3x plus 2 over 9 e to the power 2x. And then you can now add these. These two are like terms. So here on in front, you can think there's a 1. 1 plus 4 over 9 is, so I get here 13 over 9 integration of e to the power 2x cos 3x. Do you realize what happened here? These two are like terms. Now I can add them. I can add, there's 4 over 9 of e2x cos 3x here, and here there's 1 of it. So 1 plus 4 over 9 is what gave me 13 over 9 here. 1 over 3 e to the power 2x sine 3x plus 2 over 9 e 2x cos 3x. So now we can take the 13 over 9 to the other side. Basically, the 9 will multiply. The whole equation is multiplied by 9 and divided by 13. Agreed? So I can get rid of the 13 over 9. And then final answer e2x cos 3x equals to what? 9 over 13 times 1 over 3 is how much? 1 over 3, 3 over 13 e to the power 2x sine 3x. 2 over 9 into 9 over 13 is 2 over 13 e to the power 2x cos 3x. Okay, and then at the end of the integration, put a plus c. Okay, so is this to show that 1 over 3 over 13 to the power 2x sine 3x. Yeah, plus 2 over 13 to the power 2x cos 3x plus c. Yeah, so that we got something like this, right? Where p and q are rational numbers to be found and k is an arbitrary constant. So this is the arbitrary constant c. Okay, this is clear. You could name it as plus k plus c. I mean, you will name it as plus k, right? Because they've given plus k, we'll put it plus k, not plus c. Is this okay? Okay, we'll move on to question number 7. Water is flowing into a large container and is leaking from a hole at the base of the container. At time t seconds after the water starts to flow, the volume v cubic centimeter of water in the container is modeled by the differential equation dv by dt equals 300 minus kv, where k is a constant. So all the differential equation to show that the model, show that according to the model, v is equal to this, where a is a constant. Okay. So basically you have to solve this equation, right? So how do we solve a differential equation? How do we solve a differential equation? Basically in P4, what we do is we separate the variables, right? We separate the variables. Basically here I'll keep the dv here. 300 minus kv, what I have over here, I'll send the dt to the other side. Multiply by dt. But here you can see there is v here, and this side, I mean the right side is with respect to t, while the left side is with respect to v. And I need to make sure that all my v terms are on the side with respect to v. So in that case, the 300 minus kv, because there is v term, and I cannot individually move only the kv. Okay, because of the multiplication. So I had to move the entire 300 minus kv to the other side as a what? As a division. So 1 over 300 minus kv with respect to v equals to dt. And so these both of these sides we are going to integrate. So this side integrates with respect to v, this side integrates with respect to t. Are you with me? Okay, so then let's integrate 300 minus kv. 1 over ax plus b integration is what? 1 over ax plus b integration is 1 over a ln ax plus b. This is the rule, right? So I think I showed you the differential equation rules, the integration rules in the previous question as well. So here the v is the main variable here, right? So we have to take the 1 over a is the coefficient of the v variable. So 1 over minus k ln 300 minus kv equals integration of 1 with respect to t is t. And don't forget the plus. See, the moment you finish the integration, put a plus c. Now we are supposed to make v the subject, right? We are supposed to make v the subject. So I'll take the minus k to the other side. So minus k is a division. We'll go to the other side as a multiplication. Is that okay? Minus kt minus kc. Is that okay? Minus k is going as a multiplication. Minus k times c is minus kt. Minus k into plus c is minus kc. And then time to remove the ln here. How do we remove the ln? We take it to the other side as a logarithm. Ln means a log base e. So how do we remove a logarithm? Log a b equals c. So we can write a to the power c equals to b. This is the log form to index form, right? A to the power c equals to b. Likewise, here we can say ln is log base e. So e to the power minus kt minus kc is equal to 300 minus kv. Do you agree with me? Okay, so we'll make v the subject minus kv. I'll bring it to the other side as plus kv, and I'll bring this to the other side. Minus kv goes as plus kv equals 300 minus e to the power minus kt minus kc. Okay, so I think we are almost getting, we are almost there with our show that we have made v the subject, remove the k. So v equals 300 minus e to the power minus kt minus kc. Whole thing divided by k, right? Separate them out. 300 over k minus e to the power minus kt minus kc over k. Do you see? And you can see that 300 over k, that particular part I have already got it. But I'm not getting the other part. The other part has a e to the power minus kt. So I think we can see e to the power minus kt is there. But there's no a. So and we don't have such a long power here. There's only minus kt power here. How can I break this down? Yeah, so this is minus 1 over k. I'll break like this, e to the power minus kt into e to the power minus kc. You can break it off, right? Because it's we can break it off as a multiplication of same base. So e to the power minus kt into e to the power minus kc. Basically, again, the powers are added, and when you multiply the powers are added, then you can get the same answer back. So a is going to be actually what? This entire person is going to be a. Who is it? A will be the minus mark is there in the middle. Yeah, that's the plus mark. So a is going to be minus 1 over k e to the power minus kc. Do you see? So that entire part becomes the constant, because you can see 1 over k minus 1 over k is a constant. E to the power minus kc is also a constant, right? Because k is a constant, c is a constant. Basically, all of these things that I'm underlining here, these are all constants. E to the power minus kt is the only variable we have here, because it's with respect to t is a variable. Therefore, all these others are constant. So I can get them all together and make it into a single constant. That's what we have done here. Taking all the constants here, getting it together into a single constant called a. Are you with me? So v equals 300 over k and plus a e to the power minus kt. Okay, is this clear with y'all? Okay, we'll move on to part B. They say, given that the container is initially empty. Initially empty means what? Initially means at time 0. Empty means the volume, right? The V is the, at time t seconds out, the water starts to flow. The volume of the container, V is the volume. So initially it's empty means at time 0, the volume is 0. And that when t equals 10, the volume of water is increasing at a rate of 200 cubic centimeter per second. Basically, they've given you here the dV by dt, right? So they've given you the dV by dt when t equal 10. They're asking you to find the exact value of k. Okay, first things first, let's take the equation, replace t0, v0 and get what we can find. So for part B, v equals 300 over k plus a e to the power minus kt. Can you replace t with 0 and v with 0? What do we get? 0 equal 300 over k plus a times e to the power minus k into 0. That's 0, right? Are you all with me? So what do we get here? 300 over k plus a e to the power 0 is 1. Basically, I get here a equals to minus 300 over k. So we'll come to that point and then let's use those into the next equation. In the next equation, they say at time 10, the dV, the increasing rate of the volume is 200 cubic centimeter per second. Cubic centimeter per second means what? Yeah, you can see it's cubic centimeter means volume per second with respect to time. So that is dV by dt. So basically they are saying here when t equal 10, the dV by dt is 200 cubic centimeter per second. Okay, so I think you can see we already have a dV by dt equation. Are you with me? There's already a dV by dt equation. Shall we input values there? What's the equation? dV by dt equals, can you all tell me dV by dt equals to what? 300. Input the value now at time 10. So basically at time 10, okay, we don't have a place to input the t here. Yeah, first we'll have to input the t as 10 here into this equation, get the v value. That v value needs to be put over here, right? Yeah, so first we'll do that. Yeah, first we'll have to go with that. So v equals 300 over k plus a e to the power minus kd. Let's replace v equals 300 over k. A is again minus 300 over k. Shall I replace? A is minus 300 over k e to the power minus kt minus 10k because t is 10. Okay, so shall we simplify? V equals, I think that's all. Ne? We can take 300 over k out and we get 1 minus e to the power minus 10k. Is that okay? Okay, I come to this point. Now let's replace the dV by dt equation. Just remind me again, dV by dt equals 300 minus kV. So dV by dt value is given to you as 200. Well, 300 minus k times V is 300 over k. 1 minus e to the power minus 10k. Okay, so let's, yeah, k to k will cancel. So let's get the answer here. 200 equal 300 times minus 300. 1 minus e to the power minus 10k. Our end task is to make e to the power the subject. The k, you need to make k subject. 200 minus 300, okay, we'll take it here. 200 minus 300 is minus 100 equal minus 300. You want to take the minus 300 to the other side as a division. Okay. Yeah, okay. Then minus 100 divide by minus 300. 1 minus e to the power minus 10k, which is 1 over k, 1 over 3. Is okay. And then I'll take the minus e to the power minus 10k here and 1 over 3 there. So then this comes as plus e to the power minus 10k, 1 minus 1 over 3. Is that okay? E to the power minus 10k, 1 minus 1 over 3 is 2 over 3. Now let's put ln to both the sides. So minus 10k comes out, minus 10k times ln e equals to ln 2 over 3. ln e becomes 1. So k equals to minus 1 over 10 ln 2 over 3. So any equivalent answer to this is also is perfectly fine. Yeah, if you some of you might have get answers like all equivalent answers, you get 1 over 10 ln 3 over 2, which means because the minus 1 has gone inside as a power and my 2 over 3 to the power minus 1 is 3 over 2. Those equivalent answers are also correct. Okay, these equivalent answers are also perfectly okay. Okay. Part C, hence find according to the model the time taken for the volume of water in the container to reach 6 liters. Okay. They are asking you to find according to this model the time taken for the volume of water in the container to reach 6 liters. By the way, in this question, V is measured in what? Is V measured in liters? No, V is measured in cubic centimeter. So you need to be really careful about the unit. So you can't use just V as 6 here. So they're asking you to put V as 6 here. I mean not V as 6, but you have to put the V value in cubic centimeter. Liter to cubic centimeter. What's the relationship? 1 liter is 1000 milliliter, you know, and milliliter and cubic centimeter are exactly the same. So basically 1 liter is 1000 cubic centimeters. Okay, which means what? 6 liter is 6000 cubic centimeters. So basically your volume is 6000 cubic centimeter, and you're supposed to do what? You're supposed to make P the subject. They're asking you to find the answer to the nearest second. Okay, so your task is to make P the subject, shall we? So 6 liter is 6000 cubic centimeter. Be very careful about the units. Don't just blindly input the unit over here just because they give P6. Okay, always check the unit that they have measured, the given equation, what with respect to what unit they have measured, and then substitute. So V equals 300 over K. A was also minus 300 over K, right? Minus 300 over K e to the power minus KT. Okay, so let's input volume is 6000, and I think K value we just found, right? I'll take 300 over K out. 1 minus e to the power minus KT. Are you guys okay with this? And then I get here 6000 multiply by K divide by 300. Is that okay? The K goes up as a multiplication, 300 comes down, and I get equals 1 minus e to the power minus KT. So here the 0, 0, they cut. 3 times 1 is 3, 3 times 2 is 6. So I get here 20K. 1 minus e to the power minus KT. Are you guys okay with this? I'll input the K value at the last moment. Okay. So we found K is what? We found here K is minus 1 over 10 ln 2 over 3, or 1 over 10 ln 3 over 2. I'll input that at the last moment after I make P the subject. Okay. So let me make P the subject here. Minus e to the power minus KT, I'll bring over here as plus, and I'll bring the 20K to the other side. I get here plus e to the power minus KT equals 1 minus 20K. Then let's put ln to both the sides, right? When you put ln, make sure you put a bracket. Minus KT comes out ln E. Are you okay with me? What I'm doing? Minus KT comes front, and I have ln E here. This side I have ln 1 minus 20K. ln E becomes 1. And I get minus KT equals ln 1 minus 20K. Are you all okay with what I'm doing? Then let's replace the make T the subject. I get minus K goes to the side as what? As a plus K. No, minus K is a multiplication. Therefore, it will go to the other side as a division. Okay, so minus K goes as a division. 1 over minus K times ln 1 minus 20K. This is clear? Now let's replace the K value with the value answer we found. 1 over K value is minus, shall we use the answer we got at the beginning? Minus 1 over 10 ln 2 over 3. Are you all okay with what I'm doing? Into ln 1 minus 20 times K is minus 1 over 10 ln 2 over 3. So basically give the whole thing in the cal. Okay, so 1 over minus is a plus. Okay, so then I'll not give that. 1 over 10 into ln 2 over 3 times ln 1 minus 20 into minus 1 over 10. Do you see what I'm doing? I'm going through this into ln 2 over 3. Okay, so do you see all the brackets that I used? So check everything again. Into ln 1 minus 20 into minus 1 over 10 ln 2 over 3. So I had to put 2 brackets to finish off the bracket that I started at ln. Okay, do you see? So I get 41.079. They want the answer to the nearest second. So nearest second is 41 seconds. Is this clear? So this is the answer for part C. Question number 8, use proof by contradiction to prove that for all positive real numbers x and y, 9x over y plus y over x is greater than or equal 6. Okay. How do we start proof by contradiction? Always we start by saying that the given statement is false, right? We start by saying that the given statement is false. So what's the negative of the given statement? So we say assume there exists positive real numbers. Use the exact same word they use in your question, okay? Assume there exists positive real numbers x and y. Positive real numbers x and y such that, okay, so what's the negative of the given statement? Now they have told 9x over y plus y over x is greater than or equal 6. So this is where I take to say the statement is false. So what's the false of this statement? What's the negative of the given statement? 9x over y plus y over x is what? Is less than 6. Don't put equal mark. They should not even have the equal mark. Is less than 6. Because we say that for all positive real numbers, this is greater than or equal. Therefore, this negative of it is where it's less than. So we are saying that there exists positive real numbers x and y such that this is less than 6, which is the opposite of the statement. Okay, so now we need to keep on working under this statement, and we need to show what that we come to a statement, we come to a point where this is completely false, where this is something that's not possible under this particular assumption that we get something quite impossible. And then we say this statement we wrote here is wrong and the original statement is correct. That's proof by contradiction. Start by assuming the real given statement is false, and we keep on working logical steps to show that whatever we wrote here is leading to something that's impossible. And then we say that therefore this assumption is wrong and therefore the original statement is true. Okay, that is proof by contradiction. Okay, how do we work with this? Now I have an inequality. I want to work with this and show this leads to something impossible. How do I start it? It's an inequality. You know, when you're working with inequalities, you have to be really careful, because if you multiply with a negative number, the inequality sign will flip. However, what do we know about both x and y? X and y are both positive. Therefore, do you think there's any problem, any damage if I multiply the entire equation with xy? No, x and y are both positive real numbers. Therefore, there is no problem in multiplying the whole equation with xy. Okay, what do we get here? 9x over y into xy is 9x square. Y over x into xy is y square. Less than 6 into xy is 6xy. Take it to the other side. 9x square minus 6xy plus y square less than 0. Are you with me? So I think if you look at this 9x square minus 6xy plus y square, you need to see that it's actually the perfect square of a certain person. Who is it? 9x square, I think you can see you get it perfectly from squaring 3x plus y square. In the middle there's a minus. So I'll put minus, and here y square you get when you're squaring y. Look at 3x minus y square. 3x minus y into 3x minus y is 3x square is 9x square. 3x into minus y is minus 3xy times 2. Minus 6xy. And do you see that I get this person here immediately? 3x minus y, the whole thing square is 9x square minus 6xy plus y square, isn't it? 3x minus y times 3x minus y. You can manually open it. Anyway, you need to be able to see that this leads to something like this. So you have here a square number which is what? Less than 0. Look at this. 3x minus y is a perfect square, and the perfect square is less than 0. Is this something that is possible? No, this is a contradiction, because you can never have a square number that becomes negative. Always a square number is greater than or equal 0, because with respect to the xy values, you could reach 0, but other than special xy values, for every other xy value, we are always going to get positive because it's a square. Okay, so therefore this is a what? This is a contradiction. This is a contradiction. Therefore, what do we say? Therefore, the assumption 9x over y plus y over x less than 6 is what? Is incorrect, or it's false, it's wrong. Therefore we can say what? Let's give the last statement. Therefore, for all positive real numbers x and y, Therefore, for all positive real numbers x and y, what happens? 9x over y plus y over x must be greater than or equal 6. This is clear? So you must give a proper conclusion. You must give a proper conclusion in this particular sum. Okay? Okay, question number 9. Figure 1 shows a sketch of a closed curve with parametric equation x equal 5 cos theta, y equal 3 sin theta minus sin 2 theta, and theta limits are from 0 to 2 pi. The region enclosed by the curve is rotated through pi radian about the x-axis to form a solid of revolution. So basically, we form a solid of revolution. Okay, a 3D object. Okay, are you with me? We form this kind. I'm just drawing this kind of like to show you that it's 3D. Okay, so we have a 3D object here. Okay, so then they say here, show that the volume V of the solid of revolution is given by this particular equation. Okay, where alpha and beta are constants to be found. Okay, so when you're doing a solid of revolution, okay, what's the equation we do? We have two equations as far as solid of revolution. One, the Cartesian, the other one is the parametric. So in this case, I must use the Cartesian one or the parametric one. The parametric one. Okay, so what's the parametric equation? Can y'all tell me? Pi y square dx was the Cartesian equation, right? Volume of revolution is pi y square dx. Am I correct? And then that the Cartesian equation is this. What's the parametric equation? Pi y square. Yeah. Pi y square dx by d theta with respect to theta. This is the parametric equation. Are you with me? Pi y square dx by d theta with respect to theta, because we're doing the sum with respect to theta. And by the way, when you're doing this solid of revolution, do we take this whole object or do we take only the part above the x-axis and take that curve and revolve? When you do solid of revolution, what's the normal strategy? We take only the part of the curve above the x-axis. Do we take the entire thing like this? Like what they have done in here, they've taken the whole thing. Okay, but when you're doing solid of revolution, we don't take actually the whole thing. We only take the part of the curve above the x-axis. We don't take the part of the curve below. So only this part should be considered. And that part, when we rotate 360, because we are rotating it 360 degree around the region enclosed by the curve is rotated through pi radians. Sorry, they are rotating this pi radians, not 2 pi radians. That's why they have drawn the other side, right? Okay, normally what we learn in the book is we learn about rotating 360 degrees. That's why they give you only the part above the x-axis. But in here, you can see they've given you a part above the x-axis and below. And so when you take such a person and when you rotate 180, it's enough. Do you get it? Rotating it, this kind of a person, 180 degrees enough to create a 3D object, because you have both above the x-axis the graph and below the x-axis. Do you realize? In the book, in your textbook, what we do is we normally have only the part above the graph. And then in this kind of graph, we are rotating a full 360 degree to create the solid of revolution. So here, because the graph is there both up and down, having this is more than enough. Okay. Okay, now the other biggest issue is what are our theta limits? Now you can find the y square value here. Y is given. The dx by theta also we can find. And then the next thing is the next biggest thing is how do you give the theta limit? So tell me what are the theta limits here? Okay, so when you're thinking about the limits here, okay, so we don't need to really waste a lot of time here actually. You can see, for example, here they have told you when theta is 0. Shall we just input theta 0 and just see what happens? Here, when theta is 0, what do we get? X equals 5 times cos 0 is how much? Cos 0 is 1, right? So basically x equals 5. When theta is 0, just telling you, when theta is 0, x equals 5. And when what about the y value? When theta is 0, so y equals 3 times sine 0. Sine 0 is 0 minus sine 2 times 0, which is again sine 0 is 0. Basically, you can see when theta is 0, x is 5, y is 0. So where do you think that point corresponds to? That point corresponds to this q, right? It corresponds to q, which is what? The 5, 0. Basically, the 5, 0 is the point where theta is 0. Do you agree with me? And then like you need to realize it, since we are rotating it a pi 180 degree. Okay, and since we have both these ends here, I don't definitely, I think if you put 2 pi here again, you might end up coming back to the same point. If you put 2 pi, just try 2 pi here, 5 times cos 2 pi, and here replace 2 pi again, you'll again end up getting 5 and 0. So basically the other end you want is over here at this point P. Are you with me? From Q to P. So at P end, I think you can take here, you need to think a little bit here. So your critical values are either 90 degrees. So this is probably measured from the 0 here, the theta values. Theta 0 along the positive x-axis, theta pi over 2 along the positive y, theta pi along the negative x-axis. Just check when theta is pi. Let's see whether our assumption is correct. When theta is pi, what do we get here? When theta is pi, what do we get for x? 5 into cos pi. 5 into cos pi is minus 5. Y value? 3 times sine pi minus sine 2 pi. That is 0. I think you can see very clearly I get these 2 points here. So that is more than enough, right? Because if I have these 2 points and then when I rotate it to the whole thing around these 2 points from here to here, pi radians, then I get the volume. I get the solid of revolution, the volume of the solid of revolution. Okay, don't go to use 2 pi because then you start from here and then from here. Yeah, 2 pi is not included also. Okay, so we can go from 0 to pi. Yeah, we go from 0 to pi. Like, okay, we start from here and we go from 0 to pi. Okay. Wait, we'll input our limits at the end. You know what? It can be pi to 0 also. Shall we input our limits at the end? At the end of the day, we know that this is theta equals what? Pi. Okay, so we know that the limits are going to be from in between those two. Your graph is going to come in between 0 and pi. Okay, so we'll input those two limits at the end. Okay, I think we can start from, yeah, we'll put that limit at the end. Shall we input the values now? P equal pi times, who is y square? 3 sine theta minus sine 2 theta. This is y. Y square means the square of this whole thing. Dx by d theta. Can I know what's dx by d theta? X is 5 cos theta. So what is dx by d theta? When you differentiate cos, we get minus sine, right? Minus 5 sine theta. Dx by d theta is minus 5 sine theta. So let's input that value here for dx by d theta. With respect to theta, are you with me? We need to get this. Show that. We need to get the show that volume equal pi times. Yeah, we need to, there's no sine 2 theta. You can see the show that everything is in a single angle. There's no double angle, right? So basically we'll input the values here. 3 sine theta minus sine 2 theta. I think it's better that we replace sine 2 theta because we don't have any the 2 theta angles in our show that. So who is sine 2 theta? 2 sine theta cos theta. Whole thing square minus into times minus 5 sine theta. Okay, so we'll take the minus 5 out. Shall I take the minus 5 out? Minus 5 pi. Can you all open the bracket here? So this becomes, I think we can take a common thing out. 3 sine theta minus 2 sine theta cos theta. I can take what out? Sine theta out. And since there's a power 2, it comes out as not just sine, but sine square theta because there is a power 2 outside. Then what's remaining inside the bracket? 3 minus 2 cos theta square. I think it's better because if you do open the bracket, you can see that see, you can get the show that quite easily now. Do you see? Into sine theta d theta. Do you see that we are getting the show that now? minus 5 pi sine square into sine is sine cube theta, right? 3 minus 2 cos theta whole thing square d theta. Are you with me? Okay. And then, yeah, we need to make minus 5 pi plus 5, but we have to first put our limits. So from where to where does our limits go again? So I think you can see our x values, sorry, the x value started at minus 5 and ended at plus 5, right? The x value, so we'll go from there to there. Okay, so from where to where? From pi to 0. So from theta value 5 to theta value 0. Okay, because you start with the lesser x value and go to the high x value. So we can go from minus 5 to 0. And then what do we do now? It's a minus 5 pi here, right? So when you change the limits, you know what's the rule? When you change minus to plus, you get plus 5 pi and the limits are switching 0 to pi. Why are the limits switching? Because I took the minus mark in with the limit. So when you take the minus mark, or else basically we can say when you switch the limits, there's a negative sign that comes out. That negative sign and the outside negative sign becomes positive. Okay, basically if you have a to b, when you switch, you get minus b to a. This is the rule. The limits. When you switch the limits, it produces a negative sign. So you can say when you switch the limits, the negative sign comes out. Along with this negative, it becomes positive. And I get here sine cube theta times 3 minus 2 cos theta whole thing square, which is the, so this is our, show that. This is the answer for 4 marks. Are you okay? Then in part B, they say, use the substitution u equal cos theta and the algebraic and algebraic integration to show that v equal k pi, where k is a rational number to be found. So they are asking you to use a substitution. So when they ask you to use a substitution, what is the substitution? Let u be cos theta. You know, when you're doing a substitution, all the thetas must be replaced. Every single theta value is replaced. Even the d theta must be replaced, and we need to get a du. So that's the first thing we do is when they give us a substitution, we differentiate the given substitution. So what's the differentiation? When du over d theta, cos differentiation is minus sine theta. Can you all make d theta the subject here? So du over minus sine theta equals d theta. Do you agree with my working? I take the d theta to the other side as a multiplication. Minus sine theta comes as a division. So now it's time to replace, and even the limits should be replaced, right? Can you all replace the limits? So the theta limits I want to replace to u limit. Theta limits are the upper limit is pi, the lower limit is 0. Can you all replace? When theta is pi, what's the u value? Cos pi. What's cos pi? Minus 1. And what's cos 0? Cos 0 is 1. Okay, so then let's input the equation. Now volume equals 5 pi integration. First, I'm not going to touch the inside here. I'm going to let it be 3 minus 2 cos theta whole thing square. I'm first going to replace the d theta. Who is d theta? du over minus sine theta. Okay, then let's cut. I think I can remove a sine cube here. I get the sine square and I remove a sine here. I'll take the minus mark out. This minus sign can be taken out. Minus 5 pi. I get here sine square theta. 3 minus 2 cos theta whole thing square du. So basically, I need to now replace the whole sum needs to be replaced with u. And the limits also, the upper limit was minus 1, lower limit is plus 1, right? Upper limit was minus, pi was the upper limit. And that's minus 1, lower limit is 0. It became 1. Okay, so your upper limit is minus 1, lower limit is plus 1. So basically, am I done with the substitution yet? No, because if I've correctly done it, I need to make sure that there's no theta in the sum at all. Everything must be in terms of u. So I'm not done with, I can't integrate yet. Cos theta, of course, I can directly replace with the u here. What about sine square? Who is sine square? Sine square is 1 minus cos square. The main identity we learned in P2. Sine square theta plus cos square theta equals 1. Therefore, sine square is 1 minus cos square. Into 3 minus 2 cos theta square. Shall we replace the cos theta with u? 1 minus u square. 3 minus 2u square du. Do you see what I'm getting here? Limits are from 1 to minus 1. Yeah, you can switch the limits and make the negative in front positive, right? So I'm going to switch the limits. The minus becomes plus. And in the integration mark, the limits are switched. Minus 1 comes up, plus 1 comes, minus 1 comes down, plus 1 comes up. I've switched the limits. So now it's time to open the bracket. 1 minus u square stays where it is. 3 minus 2u, I think we'll have to open. Can you open it immediately? 3 minus 2u into 3 minus 2u is 3 square is 9 minus the double of these two. 3 times minus 2u is minus 6u. Double of that is minus 12u. I wrote down immediately. Minus 2u, when you square, you get plus 4u square. Are you with me? So in order to integrate, I need to further expand the bracket. So let's open 1 times. 1 times this entire person. 1 times 9 is 9. I'm opening the bracket with 1 minus 12u plus 4u square. And the other one we open with minus u square. So minus 9u square minus 12u into minus u square is plus 12u cubed minus u square into plus 4u square is minus 4u to the power 4. Is that okay? So volume equals 5 pi. Can you all add everything together? We get here 9 minus 12u. Yeah, I just have minus 12u by itself, right? And then I have here plus 4u square minus 9u square. How much is it? Minus 5u square. And then I have plus 12u cubed. Yeah, that's alone, right? And finally, I have minus 4u to the power 4. Are you with me? So this is what I need to integrate now. So I still didn't integrate. Now I have to integrate this. So let's integrate. Volume equal 5 pi times integration. 9 integration is 9u. 12u integration is 12u square over 2. You add 1 to the power and divide. 5u square integration is 5u cube over 3. Plus 12u cube is 12u to the power over 4. Minus 4u to the power 4 is 4u to the power 5 over 5. Your limits are from minus 1 to plus 1. Shall we input the limits? You must apply the limits. 5 pi times, let's input. So 9 into 1 is 9 minus 12 over 2. Shall I replace 12 over 2 as 6? 6 into 1 square minus 5 over 3 into 1 cube. Plus 12 over 4 actually becomes 3. Shall I put 12 over 4 as 3? 1 to the power 4 minus 4 over 5 into 1 to the power 5. That's the first limit. Then compulsory minus and the second limit. You have replaced all the use it minus 1. 9 times minus 1 is, shall I directly put it as minus 9? Minus 12 divided by 2 is 6 into minus 1 square. Minus 5 over 3 minus 1 to the power 3. 12 divided by 4 is 3 minus 1 to the power 4 minus 4 over 5 minus 1 to the power 5. So yeah, you need to type this in the cal. Yeah, how much is the answer for the first part? 9 minus 6 into 1 square is 6 minus 5 over 3 into 1 cube is basically 1 plus 3 into 1 to the power 4 is 3. 1 to the power of anything is 1 minus 4 over 5. So I get 53 over 15 for the first part. Minus, type the other part. So I get minus 9 minus 6 into minus 1 square. If you can do the minus 1 values in your head, that is easier, but I'm just typing it. If I would do it manually, I would just get the answer directly. Minus 1 cube, I know it's minus 1, but here I'm typing the whole thing. and then plus 3 into minus 1 to the power of 4 minus 4 over 5 into minus 1 to the power of 5, right? Is it minus 143 or 15? So in the middle there was already a minus mark and minus 143 or 15. So then 53 over 15 minus is a plus 143 over 15. And I get 196 over 15. So what happens when you multiply with 5? 196 over 3, 5. And this is the volume of, so this is the answer for the volume, right? Use substitution to show that V equal K pi, where K is a rational number to be found. Yeah. So I got an answer in terms of K pi, right? 196 over 3 pi. Okay, is this clear? Yes, so this is the end of the January 2022 P4, the unused paper.